This is very important assignment that also explains the concept of direct sum of the subspaces. Let W1 be a subspace of vector space V of finite dimension. Show that there exists a subspace W2 of V such that V is equal to direct sum of these subspaces. Now W1 is already given to be a subspace of vector space V, and we have to show that there exists another subspace W2, right, such that V is a direct sum of W1 and W2. When V will be the direct sum of W1 and W2? When what we have to show that V is equal to sum of the subspaces and intersection of the subspaces is equal to 0 element. Okay. Let's start with the proof. If you look at the diagram over here, this is V, your black colored circle. This is the vector space, suppose. And it is having a subspace W1. And let's take the basis for subspace W1 to be U1, U2, U3 up to UR. And because these are the bases of W1, which means these are linearly independent. Now if it is a linearly independent, then we know that this is a linearly independent subset of V also, right? And any linearly independent subset of V having these vectors, these can be extended to the basis of to the basis of V, right? So we can extend this linearly independent set for the basis of V. And suppose W1, W2, Ws, we have extended this set, suppose, then all these vectors forms the basis for V. The U1 up to UR and W1 up to Ws, these all now become the basis of V, right? And then we can say that the remaining part of the V, we can say that that is W2. And the rest of the vectors, that is W1, W2, Ws, these are generating W2 subspace. So when these vectors generates W2 subspace, then because all these vectors forms the basis of V and all these are linearly independent also, and we can say that then all these vectors generates these W1, W2 sum of the subspaces. Yes, we can say. Okay. So if all these vectors generates the sum of the subspaces and sum of the subspaces is nothing but complete V, then we can write that V is equal to W1 plus W2. This is what we are going to do over here. Alright. Let basis of W1 is, we have supposed that U1, U2 up to UR. These are bases for W1. So let's write the basis for W1 is U1, U2, U3 up to UR. Now since this U1, U2, because these are the bases, so these are also linearly independent. And we can also say that this is a linearly independent subset of V. Yes. So thus, there exists, alright, if this is a subset of V, then therefore, it can be extended to a basis of V. So thus there exists W1, W2 up to Ws, right, belonging to V such that the bases of V now become U1, U2, U3 up to UR, and W1, W2, W3 up to Ws. So these are the bases of V. I have already written such that over here. Up to this thing it is cleared. Okay. Now let Now the remaining ones, let's say that W2 is spanned by W1, W2, W3 up to Ws, right? For the direct sum, we have to show that first, that V is, to show that V is a direct sum of W1 and W2, first we have to show that V is equal to W1 plus W2. This we have to show, right? First I'm showing this. Now since W1 is having the basis U1, U2 up to UR, which means U1, U2, UR spanning W1. So can I say that U1, U2 up to UR, these are the generators of W1? And we have also supposed that W1, W2, Ws, these are the generators for W2. We have just now let that these forms the generators of W2, right? So these are the generators for W1. These are the generators for W2, which means W1 and W2. W1 is spanned by these vectors. W2 is spanned by these vectors. So their sum is generated by all these vectors, right? And since this U1, U2, U3, we know that this is linearly independent, right? And this is linearly independent, and W1, W2, W3 up to Ws, this is also linearly independent. U1, U2, U3 up to UR is linearly independent because we have let that these are the bases for W1. So of course these are linearly independent, which is a property for the bases. W1, W2, W3 up to Ws, we say that these are the generators for W2. For W2 we are not saying that these are linearly independent. We are saying that these are the generators for W2. Then why these are linearly independent? Because earlier we have also said that because U1, U2, U3, UR is linearly independent subset of V. So these are extended to form the basis, extended to the basis of V, right? And we have said that then U1, U2, U3, there exists W1, W2, Ws belonging to V such that all these forms the basis of V. And because these are also the bases, these are also among the bases of V, so these are also linearly independent. From here we say that these are also linearly independent. Now all these are linearly independent. So which means now these are also the generators. These are also linearly independent. So these all is a basis for W1 plus W2. Yes, we have just now say that these all are W1 plus W2 is generated by these vectors, and these all are linearly independent. So from these two we can say that, which is the property for the basis, right? So these also are the basis for W1. These becomes the basis for W1 plus W2. Now since sum of the subspaces and V have the same basis, right? So therefore what we can write? Therefore V is actually equal to W1 plus W2, right? The first thing is cleared. First part is over. Now to show that the intersection of subspaces is 0 element, right? So let's take one element from their intersection. We have to show that this is equal to 0. Let's take one element from their intersection. And because this is an intersection, so V belongs to W1 and V also belongs to W2. So therefore there exist scalars alpha 1 up to alpha r for ui's and beta 1, beta 2, beta s for w's, such that now because V is belonging to W1 and U1, U2, U3, these generates W1, which means every element of W1 is a linear combinations of their generators. So can I write V is equal to alpha 1 U1, alpha 2 U2 up to alpha r UR. And because V is belonging to W2 and W1, W2, Ws are the generators of W2. So we can say that every element of W2 is a linear combinations of the generators of W2. So because V is belonging to this, so V is the linear combinations of their generators. So W1, beta 1, W1, beta 2, W2, up to beta S, Ws. Now we say that V is equal to this and V is also equal to this. So we can equate these two. So then alpha 1 U1 plus alpha 2 U2, so on, alpha R UR is equal to beta 1 W1 plus beta 2 W2 plus so on, beta S Ws. Taking all these to the left hand side, alpha 1 U1, alpha 2 U2, so on, alpha R UR minus, okay, negative beta 1 W1, negative beta 2 W2, so on, negative beta S Ws is equal to 0. Now because U1, since U1, U2 up to UR, W1, W2 up to Ws, these are all linearly independent. We know that. So these are all linearly independent because these are the bases of V. So all these are linearly independent. Now if the linear combinations is equal to 0 and these vectors are linearly independent, so all these scalars are equal to then 0. So alpha 1 equal to alpha 2 equal to alpha 3 equal to alpha R equal to W1 equal to W2 Ws, all these are equal to 0. Now as V is equal to alpha 1 U1 alpha 2 U2 plus alpha R UR, from here we say that as alpha 1 is equal to alpha 2 is equal to alpha 3, all is equal to 0. So from here you can take this or you can say from here anything. So let me mark the first one. You can also say that from second one because beta 1, beta 2, beta is also equal to 0. We just need to say that V is 0 because the scalars are 0. So let me mark this as star from whatever way. So from the star we say that V is equal to 0. Which means V is belonging to the 0 element, right? From where we have taken V? From the intersection of the subspaces. So their intersection, because V is belonging to this, so their intersection is a subset of 0 element. But 0 element itself is a subset of intersections of the subspaces. So therefore, from these two, we can say that W1 intersection W2 is equal to 0 element because both are containing in each other. So their intersection is equal to 0. Mark this as 2. So from 1 and 2, what is 1? That V is sum of the subspaces. And what is 2? That their intersection is 0 element. So both the conditions are now proved for the direct sum. So from these two, we can say that V is the direct sum of W1 and W2. These are the conditions for the direct sum and we have proved those conditions. So hence the proof. Thank you so much for watching this video. God bless you all. Have a very nice day.